So this section's a little bit different than some of the other sections because this section has a ton of definitions and drawings that I just can't do justice. So fortunately, your book has some PowerPoint slides that I was able to edit to my liking and take out some of the, weirdly worded stuff and change it up a little bit. So that's how this lecture is going to go down. All right, so let's just go ahead and get to it. I'm sharing my screen with you. So here's hoping that you'll be able to see this. Let me go ahead and just start this from the beginning. So section 11.1, basic notions of geometry. This is just what you'll be able to do as soon as this section is complete. It's really a lot of terminology. That's really all this section is, okay? So we have some undefined terms. We have points, lines, and planes. A point, I want you to think of as the tip of a pencil or of a pen. Okay, that's a point. A bunch of points together in a straight pattern make up a line. Now, we don't really have that definition for straight. So that's why this is kind of undefined terms, right? So we have the line that's made up of a bunch of points. Now, if you take a bunch of lines and you put those together, then what do you get? Well, then you get a plane. So you can think about a point as being the tip of a pencil, the pencil being a line, and a piece of paper as being a plane. These are what we call undefined terms because they're not really formally defined, but they're the basis on everything that we build geometry on. Lines have no thickness and extend forever in two directions. Given 2 points, there's only one line that's going to contain these 2 points, okay? In order to form a line, you need at least 2 points. And we say in geometry that you need 2 points to determine a line that determines a specific line or to form a line. All right, so let's talk about collinear points. When we say the word collinear, let's break that word down, okay? Okay? Co-worker, that means it's somebody that you're together with at work. Well, collinear are points that are together, on a line. See the word linear, how it's got the word line built into it? So linear is line, co is together. So points are collinear, they're together on a line. So we say that points A, B, and C here are collinear points. D is non-collinear with A, B, and C. Okay? So we can see A, B, and D, those points are non-collinear. That sounds like a big fat word, but it really is not. Dissect it here. Non, not co, together. Line, right? Linear, not together on the same line. Okay, so linear notions. Really, I cannot believe that we're about to define the word between, but here we are. That's just because if you look at this, obviously B is between A and C, right? But the question becomes, is D, the letter D, between A and C? You might think it is, but it's not. That's because we're talking about points that are between other points on the line. D is not on that line. So that's why D is not considered to be between. Line segments. A line segment is just a part of a line and there's endpoints, right, contained. So a line segment is just any 2 points on a line and all the points that are between them. A ray is a point on a line and then all the points to one side or another. Now we can even go so far as to talk about something called opposite rays. Opposite rays have the same endpoint and together make up a straight line. However, it's possible that 2 rays will meet up and not form a line. So like these two, those are 2 rays. Those are not making a straight line. So those are not opposite rays. These 2 are meeting up at the same endpoint and they do make a straight line. So those are opposite rays. You can see the notation here that we've got this endpoint A going through point B in that direction. That's because If you're looking at a line, you're going to want to know which ray you're talking about. You're talking about the ray to the left or the ray to the right. So a lot of times we'll define a ray with 2 points. We'll say it starts at A and goes through B, or starts at A, goes through C. So you'll notice the notation here. If you put a bar across 2 letters, that's a line segment indicator. If you put like a little arrow, that's a ray indicator. If you put a double-ended arrow, that's a line indicator. We can also talk about a half line. A half line is very similar to a ray. The only difference is that the endpoint is not contained. That's all. So it's just a ray without the endpoint. That's it. Okay, planar notions here. Points D, E, and G are coplanar. Remember what we talked about co, right? Together on a plane. Points D, E, F, and G are non-coplanar. F is hanging out up there. All the rest of them are on that plane. Remember, think about a plane like a piece of paper. F hovered over here. We can talk about lines being planar, being coplanar or non-coplanar. So lines DE, DF, and FE are coplanar, whereas lines DE and EG also coplanar, but DE, EG are intersecting lines as well. Okay, they intersect at point E. So notice line DE, that blue dotted line there, and EG, that blue line, those intersect at point E, as does the line EF, right? Those are going to touch at point E as well. All right, so let's talk about some formal definitions here about these kind of lines and planes. Here's where it gets a little bit confusing. Lines GF and DE are skew lines. They do not intersect and they are non-coplanar. That's important because you usually think, oh, well, if lines don't intersect, they're parallel. No. Parallel lines are in the same plane. Skew lines are not in the same plane. Okay, so GF is doing this business and DE is doing this business, and they are not in the same plane. Concurrent lines intersect at a point, so they contain the same point. They may or may not be coplanar. It depends on how many there are. If there are 3 lines, they may not be coplanar. If there's 2 lines that are concurrent, meaning they just share a point, they are automatically going to be coplanar because 2 lines determine a plane. Now you got to get up and shake too, huh? What is it about me recording that makes my dogs just suddenly decide that they have to, jingle all the way? Parallel lines. You guys know what parallel lines are, right? Line M is parallel to line N. You write that with 2 little vertical bars. It means that they don't intersect and they are coplanar. They're together in a plane. Intersecting lines are 2 coplanar lines with exactly 1 point in common. Now, don't get that confused with concurrent lines. Those have a point in common, but they may or may not be coplanar. See, all this stuff sounds the same, right? It's really tedious. You really have to know all of the formal definitions of these and know what's coplanar, what's non-coplanar, things like that. Okay, axioms. An axiom is an unproved statement. Okay, we have these undefined terms that we build everything off of. Now we have these unproved statements that we build everything off of. Okay, there's exactly 1 line that contains any 2 distinct points. So if you pick 2 points, there's only 1 line that can be drawn to connect them. If 2 points lie in a plane, so think about 2 points on a piece of paper, then the line connecting those is also in that plane. If 2 distinct planes intersect, then their points of intersection form a line. There is exactly one plane that contains any three distinct non-collinear points. Distinct means different. Non-collinear means not together on a line. Okay, so non-collinear, not together on a line, not together on the same line. Now, what determines a plane? Remember we said the word determines means like kind of what forms it. Well, a line and a point not on the line. That's going to be enough to determine what plane you're talking about. Because there's planes everywhere. We can talk about a plane that is going in this direction, this direction, this direction, this direction. Just like we can talk about, if you just have one point, how many lines can you draw through one point? Infinite number of them. Same thing with planes. There's an infinite number of planes all over the place. So if you want to be specific and say, okay, which one particular one am I talking about? All you need is a line and a point. Two parallel lines determine a plane. Two intersecting lines determine a plane. Three non-collinear points determine a plane. That's really similar to the first bullet point up there about a line and a point not on the line, because two points determine a line, and then that third one that's non-collinear would be a point not on the line. But anyway. Okay, so this we mentioned earlier about how planes intersect. Planes can be parallel. Okay? Planes extend infinitely. Okay, so don't be fooled that it's not just a certain little rectangle. Just like lines, they extend infinitely. So, what are these weird symbols here that you're looking at? Those are Greek letters. That's the Greek letter alpha and the Greek letter beta. So we say that plane alpha is parallel to plane beta. In the other picture, alpha and beta intersect, and you can see how they intersect at a line. Their intersection isn't just a point, it's a whole set of points, and those are a line specifically. Okay, angles. When two rays share an endpoint, they form an angle. Okay? The sides of the angle are the two rays. The endpoint that they share is called a vertex. Okay? Now, as far as naming this goes, you can see that it's named either angle B, you can name it angle ABC, or you can see they put a little 1 inside there and called it angle 1. So we can name it a few different ways. Adjacent angles. The word adjacent means next to. Adjacent angles have a common side. So they share a ray, okay? And they share the vertex, the endpoint, but they don't overlap. So this is an example of two different angles that are adjacent. Angle measurements. A protractor is used to measure angles. The vertex of the angle goes on point A on the protractor, and one ray runs along the bottom of the protractor. Where the other ray comes out, that's what we use to measure on the protractor. Okay? When we measure an angle, we're really just measuring the opening between those two rays. Okay? It doesn't matter how long those lines are because, well, they go on forever. It's just about the measurement of the opening. Different types of angles. Well, we have acute angles that are between 0 and 90 degrees. We have right angles, which measure exactly 90 degrees. We even have a little symbol for that. That little, see how there's that little, looks like a little square right there in the middle? That is a symbol that's used to denote that it's a right angle specifically. An obtuse angle measures between 90 and 180. A straight angle measures exactly 180 degrees because it's a straight line. And what they didn't cover here that I could not seem to find a picture of is a reflex angle. A reflex angle measures between 180 degrees and 360. So that's a really wide open angle. You guys have seen perpendicular before. Perpendicular lines intersect at a right angle. So there's that little symbol again. See that little red box right there? That little symbol right there for a right angle. And I'm sure you've seen this before. This little upside down T. Ooh, excuse me. This upside down T is the symbol for perpendicular, just like the two vertical lines is the symbol for parallel. So this is saying that line M is perpendicular to line N. You can have a line perpendicular to an entire plane. So if you think about taking a pencil and standing it up on a desk, that line, the pencil, is now perpendicular to every line you can draw that shares a point with that pencil. So in this case, it looks like the corner of a room. So it looks like that corner, that line right there going through B and A is perpendicular to every single line coming out of point A. All right, circles. Oh, what I get for recording these late at night. I get dogs, shaking about and stuff, but hey, I don't have my kids arguing in the background, so. So a circle is a set of all the points in a plane that are equidistant from a fixed point. That fixed point is called the center, and that fixed distance is called the radius. Any point along the circle, if you take 2 points along that outer edge of the circle, the circumference as we call it, that forms an arc. The arc can be super short or it could be, like really like halfway around, more than halfway around. So that's called an arc. We're not going to use those too much. A chord is any segment with endpoints on the circle. When I say on the circle, I mean on that outer edge. That's considered the circle. Okay? If that chord specifically goes through the center, we call it the diameter. So the diameter is a chord that goes through the center. Okay? From the center out to a point is the radius. So twice the radius makes up the diameter. All right, let's do some examples. Can skew lines be parallel? Because they don't intersect. No. Parallel lines are coplanar. Skew lines are non-coplanar. So that's going back to the definitions of those. If two lines are intersecting, excuse me, are they always concurrent lines? This is a boring material. I'm not yawning because, this is boring. This is fascinating. I love this kind of stuff. Not even kidding either. It really is. If two lines are intersecting, are they always concurrent? All right. The difference being coplanar or non-coplanar. Now, because it's only two lines, if they're intersecting, then yes, they are always concurrent. Okay? That's because two lines determine a plane. So those two intersecting lines determine a plane. They're concurrent as well. Okay? So those are going to determine their own plane. So this gets a little different with three lines. So, hey, if three lines are concurrent, are they always intersecting? No. Concurrent just means they share a point. They don't necessarily have to be coplanar. Three lines can share a point, thus being concurrent, but they can be non-coplanar. So let me show you what I mean by that. So two lines intersecting, those are going to form a plane, no matter how you look at it. If you look at it flat, over, however, right? Those are going to form their own plane. Those are also concurrent because they share a point. You bring in a third line, now I could put those three like this. I can show you. I could put those three like this. Okay, now they're in the same plane. Or this guy could intersect like this, and those three be non-coplanar. So just because they're concurrent doesn't make them always intersecting. Okay? Concurrent does not have to be coplanar. Intersecting does. Will any 3 points always be collinear? Will any 3 points always lie on the same line? No. 2 points will, but 3 may or may not. Is every diameter a chord? Every chord a diameter? Every diameter is a chord because it connects any 2 points along a circle. However, a chord does not have to go through the center. So the second question, is every chord a diameter? No, it is possible to connect 2 points along a circle and not pass through the center. All right, so that finishes us up for section 11.1. I'm going to stop sharing my screen here. Okay, that does it for section 11.1. I hope this was helpful. I know there's a lot of terminology to have to know in this section. So, okay, bye.